Welcome, GeoTrig. This is 9.1 through 9.4, translations, reflections, and rotations. The essential question is, what are translations, reflections, and rotations? Let's go. So I think this is stuff from pre-algebra. That's why I'm kind of doing these sections really fast. And I'm going to blaze through this, and I think the basic idea behind all this is you just have to play around with it and you can figure it out because you're in GeoTrig. But let's go over the basic words. What's a transformation? Transformation is when you change the position, shape, or size of a figure. So it can be like I move it around, it can be like I rotate it, it can be like I scale it up and down, or squeeze it, stretch it, whatever. These are just changing the shape, changing the position, the size, shape of a figure. Now, rigid motion is a special type of transformation. This is when the distance between the points and angle measures stay the same. Oops, I should have used this one. So they stay the same. So rigid motion, there's three types of rigid motions: translations, reflections, and rotations. So here's a picture of myself. And a translation is basically when you take the picture and you just move it around, up, down, left, and right. A reflection is actually when you reflect it over some line. So it's like you mirror it. So I can, and I do it with my program right here, I can actually flip it on like the y-axis. And I just reflected my picture. So just kind of reverse. Watch, I'll even do that again. I'll reflect it again. Just watch very closely. And boom, now he's upside down. Awesome, but the beard's still going the right way. Rotations are when you just turn it around, just like this, just like it's a record or a CD or your chair if it has the rolly wheels on it. So let's actually do these rigid motions with a shape in a graph. So what I want to do is I want to move this shape here. This is a parallelogram. I want to move this right 5 units. So what this is really going to look like is I have to move it right 5 units and only right. So instead of it being this point, I'm going to count this point in the end right here. And that point, the coordinates of that are -9, 3. What is that point going to be if I move it to the right 5 units? Well, if you move it to the right 5 units, the x value is actually going to go 5 in the positive direction. So it's going to go 1, 2, 3, 4, 5, end up right here. That point that was at -9, 3 is now at -4, 3. So this is the kind of rigid motion. Translations. You might want to go up units, down units, left and right. But that's what goes on. When one point moves, every point moves. Reflections. So it's like a mirror. This gets kind of tricky here. So watch what I do here. I'm going to reflect this thing over the y-axis. So you pick some line here that you reflect it over. It's not just, oh, flip it around. It depends where you reflect it. And that depending on the line of reflection, that tells you where it's going to reflect to. So it's going to be the y-axis here. If you reflect this over the y-axis, all these points get reflected. So it's not, this shape is not, let me actually mirror, I'm going to mirror this, okay. So I'm going to leave the original right there, but I'm going to mirror this on the y-axis. I'm going to move this around. This shape would not just go right here. That's not what's going on. It's actually going to be mirrored. Notice this is 1 point off. So the nose of that triangle, I'm going to call it the nose, is going to be 1 point off in the other direction. So this triangle right here, this is actually mirrored. The original nose right here, the coordinates of that were -1, 2. Now the nose of the other triangle are going to be at 1, +2. This point up here was at -6, 6. Now that point is at +6, 6. And the point down here, which is at -6, -2, is now at +6, -2. So in this case, you got to be careful where you're mirroring. Those points, if this is 1 point away, 1 point to the left of the axis, it's going to be 1 point to the right of the axis now. It has to line up. All right, let's look at a different type of reflection. I'm going to reflect this over y equals -1. Oh, that's kind of easy. Let's do it. Y equals -1. That's not easy. That's weird. This is this line right here. It's kind of, part of it's crossing and part of it's not crossing. So you got to be very careful here. I'm going to look at this vertex right here. That's 1 down from at -6. So the coordinates of that point right now are at -6, -2. Well, if we mirror this on this y-axis, it's mirrored. It's kind of like an x-axis, but it's down 1. So I'm going to mirror it on my x-axis. It's actually going to look, and I'm going to change. No, I'm not going to change the colors. I can't do that easily. It's not going to just line up that point right there because we're not mirroring on that point. We're mirroring right here inside the triangle. So the new triangle is going to end up, well, if this point's right here, That point being mirrored is going to now end up right here at negative 6, 0. So my new triangle, if this was mirrored, is going to end up right here. So where that point's negative 6, 0, and this point right here, which was at negative 1, 2, is now at negative 1, negative 4. Because it's 3 spots up from this line, now it's going to be 3 spots down from the line. This point right here, instead of it on the original triangle, right here, that dot was 1, 2, 3, 4, 5, 6, 7 spots up. Now it's 1, 2, 3, 4, 5, 6, 7 spots down, or 7 units up and down. So that's what you got to do. I think you guys can pull this off. Let's talk about rotations. We just turn it. So you got to not know how much you turn it and about what the origin. I don't just say turn this and then you just oops, don't want to move that one. I don't just say, hey, turn it, and then you just rotate it like this. That's not what's going on here. You're rotating it about some point. So in this case, we want to rotate about the origin point right here. And a lot of these are going to just be rotating around the origin. So it's not just turning that in place. If you turn that whole thing 90 degrees, and I kind of see it like this. I'm going to draw a line. I'm going to lock this background. Oops, I'm going to move that again. Oh well, I'm wasting time on this video. I don't care. Oh, it was locked. Oh boy, I'm really messing up. Nope, no edits for me. Just going to go in. So this, I'm going to lock it so it doesn't move again. Okay, thank you. And now I'm going to take these points. I'm going to make that a group. If I rotated this, see, it's still not going to do that for me. This whole thing is actually going to be rotated where this spot change stays in place right here. So you got to make sure that line stays in place. But that whole thing got rotated, shaped to look like this. So now that shape, so this corner being right here at 2, 0, now that corner right there is at 0, 2. This corner right here, that used to be at 2, 6, is now right here at negative 6, 2. Alright, so you see a pattern going on there. Here's a table of those patterns if you want to find out. When you're rotating 90 degrees, X and Y are going to flip and your X value is going to be negative. And flipping 180 degrees, you just make the X and Y negative, and 360, it goes back to the same spot. Here's a table of that. I'm sure you can all figure it out. Anyways, let's try some examples. Pause the video. Alright, what are the vertices if the figure is translated down 3 and right 1? So yet the vertices are right there, and there. So if I translated them all down 3 and right 1, so basically this vertex is going to go down 3, 1, 2, 3, and right 1. So this is going to be new A. I'm going to call that A prime. C is going to go down 3, 1, 2, 3, and right 1. It's going to be right here. This is going to be C prime. And B is going to go down 3 and right 1. This is going to be B prime. We have a new shape between those points. It's an identical triangle, trust me. And the vertices, we'll call this first one A prime. That's at negative 1, negative 1. Well, B prime is going to be at 2, negative 2. And C prime is going to be at 1, negative 3. Try a different one. Pause the video. Okay, so reflecting over the y-axis here, what are the coordinates of the vertices? Well, all these points are going to flip across the y-axis. Neat thing about B does not move. So B and B prime, the new point, are at the same spot. Now A, since it's at 4 up here, and this is at 4, and it's 3 to the right, it's now going to be 3 to the left of the y. Now it's going to be 3 to the right. This is going to be A prime. C is now 1, 2, 3, 4 to the right. Now C is going to be 4 to the left. 1, 2, 3, 4. This will be C prime. I've got all 3 of those, so I'm going to draw my perfectly identical triangle that's just been translated. So perfect. And the coordinates of each of those vertices, A prime is going to be at 3, 4. B prime is going to be at 0, 1. And C prime is going to be at negative 4, positive 2. We got one more. Pause the video. Okay, I want to rotate 270 degrees around the origins. The origin 0, 0 right there. What are the coordinates of the vertices? So it's going to be, this whole shape is going to be rotating 270 degrees. So it's going to go, and that new shape should be over here somewhere. So what I'm going to do, and there's a few ways I can take this. I can just follow my formulas from up here. Or I'm going to actually just follow this bit by bit. If you rotated this whole shape around the origin, this new point here, see how it's one dot up? If it's rotated just 90, that point would be right here. But rotate another 90, it'll be right here. And rotate another 90, it's right here. So I prime would be right there. All right, let's look at H. H is right here. You rotate it 90 degrees. H is 90 degrees around that origin. It's kind of that corner from that origin. Rotating it 90 would then put it at right here. And rotating it 90 again would be putting it right here. And rotating 90 again would be right here. So my H prime is going to be right there. My next spot, F, from the origin it's 3 this way and 2 up. You're rotating it, those are going to flip. It's going to be 3 out on this axis and 2 to the left. And rotate it again, it'll be 3 out on this axis and 2 to the left. And one more rotating, it's 3 up and 2 to the left. It will be right here. This will be my F prime. Now for my G, since it's rotating around the origin again, that's 3 to the right, 1 down. It's going to be 3 down, 1 to the right, 3 to the, that's 90 degrees. Here would be 180, and this would be 270. So this will be my G prime. And I can make my perfect shape, which will look just like this. I'm doing it right on top of each other. Ooh, that last line was bad. These are straight, that's an angle, and that's an angle. And those are identical shapes rotated 270 degrees. So the coordinates of the vertices, I'm going to write H prime is going to be at -1, 1. I'm going to write G prime is going to be at -1, 3. F prime is going to be at 2, 3. And I'm leaving out I prime, and that's going to be at 1, 0. There we go. And we could have actually just followed the formula, I think. If we went 270 degrees, you flip the y and the x and then make your new y coordinate negative. And that's what's going on. I flipped the h. Yeah, that's exactly what went on. So you could have followed that table. That's it.